6.1 is about scatter plots, correlations, and lines of best fit. And we're going to focus even more about lines of best fit in 6.2, where we start talking about residuals. But in 6.1, we're going to review what is a scatter plot, how do I read a scatter plot, and then we're going to talk about something called a correlation coefficient, which talks about how strongly related two variables are in a data set. So, our essential question, how do we identify a correlation in a scatter plot and determine its strength? So just as a reminder, a scatter plot is a graph that shows the relationship between two data sets. In this scatter plot that you can see graphed to the right here, we're looking at the age in months of a baby and the weight in pounds of a baby. And now we're going to answer a few questions looking over that scatter plot. So question A says, what is the weight of the baby when the baby is 4 months old? So this is basically asking us, when x equals 4, find y. So when x equals 4 months, I'm going up to the y-axis. It looks like the baby is 14 pounds when it is 4 months old. Question B is asking what age, so that's asking us for what is our x, what is the age of the baby when it weighs 17.2 pounds? So when y is 17.2, what is x? So I'm going to look on the y-axis. 17 is going to be somewhere between 18 and 16. So that looks like this data point right here. What is the x at that data point? X is going to be 8 months. 8 months old. Now, if you were to sketch a line passing through as many of these points, or drawing a line that was as close to these points as possible, would it have a positive or a negative slope? So let's see, if I drew a line like this, that hits a lot of those points. Does that line have a positive or negative slope? Well, if I drew my little person here, he's walking uphill when we look from left to right, so it would have a positive slope. And that leads us to our next idea about a correlation. If you look at a data set and you can identify if there was a line, would it have a positive or negative slope? That's actually identifying, is there a correlation or a relationship between the data sets? So a correlation is just that. A correlation is the relationship between the two data sets. Are they related? It makes complete sense that as a baby gets older, it starts to weigh more, right? They are born very, very small, and then they start eating and eating and eating and growing. That makes sense. There is a positive correlation, meaning as age gets bigger, so does the baby, or as age increases, so does the weight of the baby. The way that we have defined correlation in statistics is using the variable r and something called a correlation coefficient. And a correlation coefficient is a number between -1 and 1 that describes how strongly correlated a data set is. So let's look at some examples of R values. So a correlation coefficient is something that is calculated using a calculator. It is not something that you calculate by hand. And when you calculate it using a calculator, it's going to give you a number somewhere between -1 and +1 to tell you how strongly two things are related. So if it is a negative number, that would mean that there is a negative relationship between those two things, right? Looking here, r equals -1, that looks like almost a perfectly straight line. And the more aligned, or the more perfect the line that you could draw through them is, the closer it should get to -1 if we're talking about a negative relationship. If you look at +1, again, that looks like a perfectly linear relationship, has an R value of exactly 1. A perfectly linear relationship that has an R value of -1 is when that slope is negative. Everything in between, again, is something that is calculated using a calculator, but that we can get an idea of how it looks. So if you look at this R value here for -0.8, if I drew a line, I can tell that that has a negative slope, but the points are definitely not as close together as if I drew a line here, where I could draw a line that actually goes through all of those points. So the closer the points are to your line, the closer your R value is to -1 or +1. Here again on R equals -0.3, I can tell that this kind of looks like a negative slope, but those points are really, really far apart, which is why that R value is not so strong. It's not close to -1, it's actually closer to 0. And if you look at what happens when R equals 0, I don't even think I could draw a line to figure out if there was a positive or negative slope here, because I can't tell. And that means that there is no correlation at all. Over here on the right-hand side, this looks positive, like it looks like it would have a positive slope, but they aren't very close together. So that's going to be somewhere like R equals 0.3. The closer they get to your line, or the closer the points are together, the stronger or more or closer to 1 that relationship would be. So you aren't going to be giving R values. You are just going to be focusing on how strong or how weak a correlation is. So a line of fit, which we have just briefly talked about, a line of fit can be drawn on a scatter plot to determine how close together the points are. To determine if a set of data has a positive or negative correlation, you're going to be looking at the slope of that line. So again, it's all about that slope, Here I go singing to you again. So I want you to pause the video in just a minute and look at the examples on 1, 2, and 3 below. I want you to sketch a line that passes through or is really close to as many of those points as possible, and then determine, is there a strong positive, a strong negative, a weak positive, a weak negative, or no correlation because you don't even know how to draw a line based on that data set. So go ahead and pause the video and draw those lines, and then decide strong or weak, positive or negative, or no correlation at all. Okay, looking at number 1, I could draw a line like this. And that line seems to be incredibly close to all of those points. So I would say that this is a strong correlation. And if I drew a little person on this, he's walking uphill. So this is a strong positive correlation. Number 2, I don't even know how to draw a line. I could draw a line like this maybe. Or I could draw a line like this. If you can't even tell if your line should be positive or negative, you've kind of answered your own question there. There is no correlation here. I can't tell if it's positive or negative, so it must be no correlation. And then number 3, these lines look like they're getting, these points look like they're getting smaller and smaller and smaller. I could draw a line that looks like this. I would say that slope looks negative, but it doesn't look very strong. If I compare that to number 1, this is a very weak correlation. So this is a weak negative correlation. So identifying a correlation, you're saying, if I drew a line to represent this data as best as I could, would it have a positive slope or a negative slope? And how close to the line are all of those data points? The closer they all are, the better that line is to represent it. So the stronger the correlation. A correlation coefficient is a value between -1 and 1 that is calculated using a computer or using a calculator. Your job is really to be able to look at a scatter plot and identify, is there a correlation? Is it positive or negative? Is it strong or weak? Looking forward to supporting you on this in class. Thanks for listening.